The James Webb Space Telescope, additionally known as Webb or JWST, is a logical pioneer that has uncovered astonishing insights concerning stars, planets, cosmic systems, and other intriguing vast peculiarities, as well as setting new principles for logical fervor. Webb is hailed as the revered Hubble Space Telescope substitution. People from one side of the planet to the other are trading photographs or utilizing crude data to make new bits of knowledge. 1 year has passed since the considerable James Webb Space Telescope divulged its first-ever memorable picture of the universe, stunning space experts all over the world with its phenomenal detail. However, its latest finding is a frightening image of the universe that we have never seen before. What has been found up to this point by the James Webb Space Telescope is suggesting more conversation starters than it solves. Researchers join us as we investigate how the James Webb Space Telescope captures the most alarming picture of all time found in history. The successor to the Hubble telescope divulged new data about star formation, universe consolidation, and the early universe. Only 1 month after the initial photographs were released, the pictures were amazing, revealing the universe in great detail. From that point forward, the quantity of discoveries has soared, giving researchers a huge data goldmine. James Webb Space Telescope observations of vast tarantulas, record-breaking space smoke, stars nearly experiencing cosmic explosion blasts, and other amazing heavenly objects have been recorded. This satellite observatory's cutting-edge technology allows us to peer farther into space than ever before, uncovering previously unknown insights about the universe. Another time in stargazing has unfolded. On account of the photographs, which can be so detailed, as a method for honoring the first year of the James Webb Space Telescope's activity, NASA delivered a picture that shows a little star-forming region in the Loopy Cloud complex. The picture shows planes ejecting from infant stars as inestimable dust billows of various colors. Impact molecular hydrogen makes up the red dust, and the presence of a circumstellar disk stirs up misgivings about a few stars, suggesting the chance of planet formation in the far-off past. The picture might show enormous pandemonium, but according to NASA, this heavenly nursery is small and serene compared to others. Moreover, a large number of the youthful stars in this region are about the size of our Sun, or perhaps even much smaller than the closest star-forming area to Earth. This image was captured by the primary camera of the observatory, the Webb Space Telescope's near-infrared camera, which captures cosmic pictures in 2 distinct infrared ranges at the same time. Besides, the Space Telescope has improved our knowledge of exoplanets, or worlds that circle stars other than our Sun. James Webb is particularly good at checking large, distant cosmic systems. The satellite observatory found its first exoplanet, LHS 475b, at the beginning of 2023. The planet is 41 light-years away and has a size comparable to Earth's. According to NASA, James Webb is the sole functional telescope capable of analyzing the atmosphere of Earth-sized exoplanets. The researcher responsible for the study group that made the discovery found that the results demonstrated the telescope's accuracy, and rough exoplanets are now a new frontier for stargazers to investigate. After that, the James Webb Space Telescope found evidence of long-lost worlds that, from a theoretical standpoint, shouldn't have existed. Eva Snine College and his international cosmic team have found 6 enormous, ancient universes called universe breakers. They have the potential to impact the way we contemplate space. These gigantic systems might have appeared between 500 to 700 million years after the Big Bang. According to the analysts' results, the telescope's infrared sensors detected them using these instruments, allowing us to look back in time to around 13.5 billion years when stars and cosmic systems were much older. The vastness of the universe breakers has left researchers dumbfounded. Systems in the early universe should have been 10 to 100 times less massive than that. Their measurements show that these 6 objects might be billions of times heavier than our Sun. The amount of stars in one universe may be 100 billion times heavier than our Sun. Does the prospect of trying to comprehend something so huge give you the creeps? Despite the fact that most universes during this period are relatively small and are only extending slightly, some giants reach adulthood much faster than others. It is unclear what would cause this or how it would work. Penn State College Space Science and Astronomy Associate Professor Joel Leha expressed his bewilderment at the discovery of a new class of objects formed at the Big Bang. The discovery that the development of massive worlds began at the very start of the universe's history challenges many of our previously held beliefs about the state of science. It seems our discovery is so strange that it presents challenges to the scientific community. It throws into doubt the entire concept of how universes formed in the early universe, much larger than anyone expected. Most of the universes in this category are considered infant systems, as they are still in the process of development. However, universes as old as our own have been found in the early universe, which was previously believed to be its beginning. Spectrometry, which separates light into its component frequencies to enable more precise distance estimations, is still needed to validate the results, which have researchers scratching their heads. There are only a handful of recently discovered objects for which distance and mass have been confirmed. If the data is accurate, the system's formation would have to have been significantly more effective and quick than previously thought. The fact that the spectra verified our standard working system's derived assumptions from the visuals is promising. For years, researchers have sought to interpret cosmic history. However, a single piece of equipment might hold the key. Observations of reality have long piqued the interest of researchers, so it's no surprise that conflicting realities presented by telescopes could lead to a current lack of clarity. Cosmologist Dr. Katie Mack has decided to offer her insights into the matter in order to explain how this could be happening. She pointed out that the JWST has been providing evidence of universes that appear to have begun or developed much earlier than researchers had expected from their models. However, as Mack called attention to, the telescope is capturing images of systems more than 13 billion light-years away, and they are somewhat blurry. It seems that there hasn't even been enough time since the Big Bang for these enormous cosmic systems to have formed by the dates that cosmologists have been seeing from the telescope. Many in the field were concerned that this casts doubt on various theories, including dark matter and the Big Bang. However, we should look deeper into the evidence to find out for sure. The telescope captures amazing views of close nebulae, but distant universes appear like fuzzy little dots. The reason is that different wavelengths are affected by different parts of the light spectrum. The Webb telescope can detect light from a source in two distinct ways. It may use a spectrometer, which works a bit like a prism in analyzing the brightness of each color, or it can use filters that block all but a select range of wavelengths. They can then compute the redshift of the system by comparing this data to spectra predicted for universes with the same attributes. What this redshift reveals is the precise moment in astronomical history we are observing. It turns out that many systems have an excess of stars, or stars that were too young when they should have lived. According to studies of model spectra, there are various possible explanations for this. The photometric readings could have been off due to issues with the telescope's alignment, or they might have been observing a group of systems that aren't representative of the norm or an incredibly tiny region of the sky. Another possible explanation is that world-range models are intended for closer systems, which don't work as well with systems farther away. On the other hand, cosmologists may face the exciting possibility of having to completely reassess cosmic evolution if these systems are indeed incredibly massive and previous estimates were wrong. However, this is hardly the only area where researchers have missed the mark. Despite technological advancements, planets that are too large to exist have researchers completely puzzled. None more so than the discovery of a planet considered too massive for its own existence. This has prompted a reassessment of our system's understanding of planet formation and nearby planetary group design, as well as the models created by cosmologists in the fallout math. A planet that is multiple times as massive as Earth has been found, according to research out of Penn State. Rumors suggest that this planet is in a planetary system around the ultracool star LHS 354, a star that is multiple times less massive than our Sun. According to a news statement, the tiny star has a mass ratio multiple times higher than Earth's ratio to the Sun. Previously, researchers didn't completely believe such a situation was possible, but new evidence shows that the largest planet in our nearby planet group is truly orbiting one of the universe's smallest and coolest stars, a tiny star. We still have barely any familiarity with the universe, and this discovery demonstrates it even more. A planet of this mass orbiting a star with such a low mass defies our assumptions. These stars might have originated in large clouds of gas and dust, and planets might form from the gas and dust that remain in the disk of material around the infant star. However, It is not speculated that the planet-forming disk surrounding the low-mass star LHS 30154 contains enough solid mass to create this planet. Nonetheless, it exists. Consequently, we must now rethink our speculations regarding planetary development. A fitting analogy would be to compare the star to an outdoor fire. In order to maintain your internal temperature, you would need to get closer to the fire as its temperature decreases. Planets that need to be hot enough to support liquid water should be closer to stars with lower temperatures. If a planet is in a tight enough orbit around an ultracool star, we can observe the planet's pull on the star's light or spectra, which causes a slight change in the star's color. However, gaze upward at the sky. A new, amazing picture of the ice giant Uranus, including virtually its dusty rings, which had previously been challenging to photograph, has been captured by the James Webb Space Telescope. For the fainter rings, which have only been seen by the Voyager 2 and WMK Observatory on Mount AIA in Hawaii, the picture is a stunning demonstration of the telescope's sensitivity. Uranus, which is 1.12 billion miles from the Sun, has 13 recognized rings, 11 of which are displayed in the amazing new picture from the Webb Space Telescope. Rather than Saturn's even rings, this planet's peculiar axial tilt causes its rings to appear vertical. The two outer rings were not recognized until the 1986 flyby of the Voyager 2 spacecraft because their dusty composition made them less visible and more challenging to photograph. The 9 major rings were already known, but in 2007, photographs captured by the NASA Hubble Space Telescope revealed 2 more fainter outer rings that are not visible in the Webb photos. Webb has the potential to find them, according to researchers. A planet's ring system provides important information regarding the planet's origin and formation. Uranus is an incredibly unusual globe with its skewed orbit and absence of internal heat. Therefore, any information regarding its past would be greatly appreciated. The unusual atmospheric composition of the gas giant planet Uranus is something that researchers are hoping the telescope can reveal, as no other telescope of this scale has ever been able to observe infrared light. The JWST allows us to inspect Neptune and Uranus through a unique, sacred lens. Telescopes that use visible light, like Hubble, can't observe infrared frequencies, but infrared imaging can reveal previously hidden depths and features. Moreover, a special film of a star nearing death has been obtained by the James Webb Space Telescope. With JWST's late 2021 launch, the fading star picture is among the first faultlessly recorded occurrences of its type. The massive, dying star Wolf, R124, was captured on film by the telescope's infrared lens as it shot out gas and dust into space. It is believed that this celestial event is happening 15,000 light-years from our planet. The image, which was provided only by NASA, shows a glowing purple remnant of the star's core, which was previously a thin cloak of dust and gas causing the star to erupt. The stunning image is an enhancement of the one that the Hubble Space Telescope captured a few years ago, in 2015, before the JWST was launched. The star, undergoing significant transformation, was recorded by the Hubble Space Telescope. It appeared more like a bursting ball, but because our technology couldn't capture the finer details, the destruction caused by Wolf, R124, is now clearly visible. It is believed that the Pod star, located in the Sagittarius constellation, is multiple times greater than our Sun and has expelled enough gas and dust to cover 10 suns at the moment.